1.6, reflection, rotation, and symmetry. Reflection, rotation, and symmetry. Okay, line of symmetry or an axis of symmetry. They are the same thing. There are two different terms for it. They say line of symmetry, they say axis of symmetry. What they're talking about is the line a figure is reflected over. So those two terms are interchangeable. So on your homework, they can ask you either way, okay? They are going to ask you either way. So the line a figure is reflected over. When you have a vertical reflection, okay, this always messes with my brain a little bit. When you have a vertical reflection, it flips over a horizontal axis. So this is a vertical reflection. So if I flipped it over this axis, it would fold on itself. Okay? When you have a horizontal reflection, it flips over the vertical axis. Okay? I can fold it, it lays on top of itself. That's how I know it has symmetry. This graph right here, which is like a cosine graph, has no symmetry because when I divide it in half, if I flip it over that horizontal reflection, it doesn't graph on itself. Okay? So, to determine if points are reflected over an axis, okay, if it's over an x-axis, the x coordinates are equal, the y coordinates are opposite. Okay? Which means if my original coordinates were xy, okay, my new coordinates become x negative y. Okay? So if my coordinates like here are 4, 2 originally, then my new coordinates are 4, negative 2. Okay? So my axis of symmetry here is the x-axis. This dot is being flipped over there for this portion of the line. Okay? Your x coordinates are equal, your y coordinates are opposite. And this would be a vertical reflection because it has a horizontal axis. Confusing, I know. This one is a y-axis example. Okay, the x coordinates are opposite, the y coordinates are equal. So x, y would be my original, and it would translate to negative x, positive y. In this case, this one starts at 2, 3, and then it goes to, it reflects to negative 2, 3. Or it should, oh, I lied, it's 3, 3. I just can't read my own graph. And negative 3, 3. Okay? So the x coordinates are opposite, y coordinates are equal, and it is the y-axis that is my axis of symmetry. You're going to have to start labeling axes of symmetry on things with the dotted line like that, or with telling me y equals this or x equals this. In this case, if you wrote it, it would say y equals the y-axis, or 0. It would say y equals 0. When I graph 0, that's my axis of symmetry. Okay, so then they give us some picture examples. Also, once again on your computer, if you go to AMSCO Math, they also have like 4 different types of activities. One with dots, like 2 dots like this with a line, and then they have one with an angle, and then they have one with like a monster that has 4 points, and you can plug in things to figure out if it has reflection over what axis. Okay, so then you are given 3 pictures here, 3 different types of flags, okay? So this first one, they want to know, does this have symmetry? Does that first picture have symmetry? If I fold it over itself, would it be equal? Pretend that my pictures are perfectly square and everything, because I tried drawing them, but you know. Okay, so would that have symmetry? Would it fold over on itself? Yes, because the triangles are even, everything's even. This has symmetry. Okay? Does this picture have symmetry?
Yes.
Yes. Okay, the sun or whatever this is even, all this stuff is even that comes through here. Would this flag have symmetry? Why not? Okay, because when I fold it, this has like a cross shape here or squares here, and that wouldn't reflect it all over there because it's just stripes. Okay, and I can't put symmetry up and down or horizontally on this one. Okay, on this one you can only do symmetry vertically, right? And I can only do symmetry with a horizontal line on that. Are there shapes where you could do symmetry with both? Like what type of shapes? Anybody know? A circle. A circle has infinite amounts of symmetry, right? Does a regular trapezoid have symmetry? A regular trapezoid? Like this? How would that have symmetry? Vertically or horizontally? Oh. It would have a vertical part of symmetry, which makes it a horizontal reflection. I know, so confusing. So yes, I would have here, correct? What about let me think. Stars can, if they're made with point, you can go down the middle of it, right? Okay, so you're going to be looking at lots of pictures tonight, deciding if it has symmetry. Now, if I have something that wants me to reflect a point, let's say I have like this graph right here. It wants me to reflect this about the y-axis, which means the y-axis right here is going to be my line of symmetry. Okay, so I'm reflecting every point about the y-axis. What do those points A, B, and C become? A is 1, 2, B is 3, 4, and C is 4, negative 3. How would I graph that? What would that look like when I reflect it? A is 1, 2, B is 3, 4, and C is 4, negative 3. Let's start with point A. Where would that reflect? Negative 1, 2? Why do you say negative 1, 2? Okay, and we also know that if we're reflecting something over the y-axis, my x-coordinate is opposite and my y-coordinate stays the same. So my new thing when I reflect this for A, okay, becomes negative 1, 2. So you can do it through picture, or you can do it through algebra, okay? So that's my mapped point, my new point. So where does B go then? Negative 3, 4, good. Negative 3, positive 4. B is negative 3, 4. Where would C go? Negative 4, negative 3, right? Negative 4, negative 3. Okay, that becomes C. And then if I connect these, because I'm so good at this, okay, it is the reflected image. Do you see that? Okay, draw it out if you need to draw it out. Draw it out and visualize it. But that's what the reflection looks like. So if I fold that piece of paper, it will fold on top of itself. Even if on your homework you want to take one piece of graph paper and draw it and then fold it where it's supposed to be folded to see it, do it that way if that's what it takes. Okay? Anytime you need to do that on a test, quiz, anything, do it if that's what it takes for you. Because if it doesn't match up, then you know that it doesn't have symmetry. Okay? What type of symmetry could take place with a shape like this? Let's go here. Let's go. Okay. You're going to pretend that's perfect again. What type of symmetry? What? Okay, if it has a vertical line of symmetry, then it has horizontal symmetry. So vertical line, horizontal symmetry. Can it have a horizontal line of symmetry also? Yes, so this one has 2. Okay? So that's what we're doing on our homework tonight. We're looking at pictures. We're deciding that we're moving dots or triangles over an X or Y axis for different types of symmetry. They might give you questions like one that we already went over. How many different axes of symmetry are there for a circle? An infinite amount, okay? They might give you questions, how many different axes of symmetry are there for a triangle with exactly 2 sides having equal length? Which means what type of triangle do you have? Okay, so I have a triangle that's like this. How many axes of symmetry are there in that? 1. Just 1 that goes straight down, right? Okay, so that's the type of stuff you are going to be asked tonight on your homework. How do we feel about that? Questions? Okay, let's do this.
So this